All right, so now we are back and we're going to take a look at the next tool that we can use with digital elevation models. So in this case, we're going to take a quick look at slope. Slope in this case is another 3D analyst one, and it also appears in the spatial analyst toolbar. But this one is taking a look at what is the gradient, right? So what's the gradient of an area? So if you have very flat land, it's going to have a gradient of 0. If you have the sheer face of a cliff, that's going to be a lot closer to 85, 90 degrees, right? So what is the actual angle that you have? So in this particular case, same as everything else, we have what we want to have as our input. In this case, you again want to go directly back to your elevation model, and same thing, you want to give it a decent name. So slope 2012 is going to be the one in this case. Now you have some options here in terms of what you want, right? So you can do this as percent rise or degree. We're going to keep it as degree. You can take a look at it in geodesic, so on the ground, or planar, as in on the map. We're going to keep that as our planar. And then again, same thing here with the Z factor. How much do you want to artificially stretch out your area? And so then you also have your GPU, then CPU in terms of how it's going to run. So we're going to keep all of that as its default in this particular case. Again, this is just giving you an idea about how this looks. Now, with the slope, one of the things that you may be a little bit more familiar with that the slope kind of runs similar to or ends up having an output similar to is a topographic map. So topographic maps will have these lines or these contours of common elevation, and the closer the lines are together, the higher the slope, the farther apart the lines are, the lower the slope. This is very similar to how this output ends up looking if you don't adjust what the actual, if you don't adjust what the symbology is in this particular case. It looks very similar to that type of map. So think about what those maps are kind of useful for, right? So it is in this case taking a look at slope if you look at it on the side, but how it kind of looks ends up being a little bit along the lines, right? You can see how you have a whole bunch of lines in this section, right? And you can see how there's not a lot of lines in some other areas, right? This is very similar to a contour style map. So if you think of it kind of similar to a contour style map, then it'll help you kind of sort out what this type of thing, or what probably is the closest equivalent to this type of map. So you have a lot of area here, which is under this 1.72 degrees, right? So this is very, very flat. And then you have this sharp or 90-degree slope that is, or just about 90-degree slope here that is headed into the water. And then you also have this hill here with a fairly middle variety of things. And then over in here, you can see that it adjusts how some things look, right? So very clearly here, you can see that there are circular things going on and then flat areas underneath it. So in the hill shade, right, we can then start to look and see what these are. And so these ones obviously are looking like they kind of have hills almost, or something to that effect. And then if I take that off further, you can still kind of see these circles that are going on here, but in the slope, you can very clearly see that there are these circular bits here. Now, what those circular things are, this is something that you can think about what's down on the coast that might look like that. But it is very, very useful to have a slope to see where are there straight lines, where are there boundaries of things oftentimes, where are there topographic features, and also in particular, where are these urban features as well, right? So think about buildings, think about water holder, water towers, those type of things, any sort of canisters, any sort of flat areas. So looking at those differences and seeing, where those differences are. So this is the slope one. And so you can do things like analysis with this, a little bit less so because Mississippi is so flat. But if you're headed over in places, let's go with, if you were instead up kind of in the mountains, or something to that effect, right, you might end up seeing that, if you're kind of over in something like Atlanta or Georgia, up in Tennessee, those types of areas, then you might end up finding that something like this is rather useful for things like average slope. So if we're thinking back to the lab that we did last week, right, where we were then looking at, where are these areas, you can take a look and see whether or not there's something in those protected regions that was based on slope, or maybe same thing with Wisteria, maybe in the invasive species component, you can see whether or not there's an average slope that is more favorable for these protected areas or for these less protected areas. Right, in this case, because we are dealing with sea level rise, we're very much going to be looking at these flat areas and seeing how much of those are likely going to end up being taken over. So this is the slope, right? And so again, you're probably going to want to do that and take a look at that for the 2020 area as well, and then put that into your lab report. You're going to want to zoom into an area that you think is kind of cool, and then put that into your lab report. So I'm going to stop this one and then we'll be back in a sec.